All right, so what we're gonna do is talk about how to take an integral of this. Um, and you're gonna see some problem. Do you see some problem?
Yeah.
Okay, so the problem is usually we have u equal to inside, right? The outside usually have one lesser degree. So in this problem is, do you see that this and this are the same degrees, which is first power. And so in order to x plus 1 here, this should be a constant here. Okay, it should be a constant here. So Laura, pay attention here. Okay, so make sure you understand why this question are different before you get thrown out on the actual test. So u is equal to x plus 1. You see this. Normally I will do du equal to dx. And I will have x square root of u and it's du. But the problem is nothing cancel. I still have an x and u at the same time. So that means I cannot do anything with the integrations. So what would you suggest to do from here?
I would integrate at least the square root of u.
You cannot just integrate a small part of it. If you integrate, it has to be the whole thing. You cannot take out x either. You cannot integrate with x and integrate with absolute value. No, you cannot do that. Square root u.
Is there a
What?
Wasn't there like a rule or something that said when you distribute?
I cannot distribute because they are different variables. I mean, you can distribute inside, but it's going to be square root of x squared u. It's not going to do anything. The whole idea, you want to make sure everything is in u. It's easier than this. You just have to think about different. I cannot integrate unless they are the same variables. What'd you say? You might be on the right track.
So plug the x plus 1 back in. That won't work though.
Yes?
Could you solve for x and then u equals x plus 1? And then plug in
Solve for what?
x?
Yeah. Would that be u minus 1 times square root of u du? Now it's everything in terms of u.
Why in order to take the integral does everything have to be in terms of u?
What?
Why in order to take the integral does everything have to be in terms of u?
Everything have to be in terms of the same thing in order to do to respect to u. Or in antiderivative. So therefore, this one can distribute backwards, so it's going to be u to the 3 over 2 minus u to the 1/2 du. And this one's u to the 5 over 2, 2 over 5, minus u to the 3 over 2, 2 over 3, plus c. And there we go, is your answer. This one's a little bit different. And that's it. So sometimes you gotta know when to do this. When do I know this? What is the things that it tips you off?
If they're all the same degree.
Same degree here, right? If they're the same degree. Right. Or another possibility is, what if outside is higher degree than inside? That still work. So it could be outside is higher or the same. That's only in time. So we're gonna give it a name. We're gonna call this is called back substitutions. Is it back sub? There's no actual name for it actually, but I'm just gonna call it back sub. So that way I can always know, like, this is when I use a back sub if you have the same degree. So this is how I think about relationship every time. Like I told you guys before, you don't study the whole thing. You study the relationships. You understand how relationship works. Hopefully you have no problem with algebra, but if you have problem with algebra, then you can still fix your algebra. But in calculus, you just have to understand how relationship with each other. When do you do this? Instead of trying to memorize, each steps, how things work. Make sure you understand the relationships. Okay, questions here? Okay, now you can try one. You guys finish?
Did you add or subtract instead of add? For the next Yeah, you're supposed to add the tables.
This is what I got. I don't know. It's okay.
Yeah, my signs are reversed as well.
Because du is negative.
But why?
So du negative, just become negative square root u. Negative square root u distribute to negative u is u to the 3/2, positive. And that 2 becomes negative.
Oh, so like because du is wait.
Because du is negative, right? So I'm going to put a negative sign in front of square root u.
Oh, okay.
Make sense? Okay. We're going to talk about one thing very, very important. It's a definite integral. But I need you to do it in this way in order to get maximum amount of credits on AP exam. And even the kids in Calc BC still have slightly problem with this, which is kind of frustrates me. Now this is a definite integral with the U substitutions. Okay, this is a definite integral with the U substitutions. What will I set U as?
X squared plus 1.
X squared plus 1, good. Du is equal to what? 2x dx, good. So far it's fun. Now, du over 2x is equal to dx. Okay. Now, I want you to make sure you do this in terms of red thing here. Is you have to do this, especially on multiple choice on AP exam, that's how you get credit, is to actually change the boundaries. What you're gonna do is you not only change everything in terms of u, the boundary need to be in terms of u. So for example, that this is 1, this is 0, this is the x bound. This is x, right? We need to change that to in terms of u. So that means I'm gonna plug in 1 into the here. Okay, so it'll be 1 square plus 1 is equal to 2. This is called the upper bound. I write down UB, which is the upper bound. 0 squared plus 1 is equal to 1. This is called lower bound. Now what's interesting is this, you will have u to the 3rd power here. Of course you still have x, but that's okay. That x is going to cancel out eventually. So cancel out with this x. So this x cancel out. But now this is very important. You are not changing using 1 and 0 anymore because there's no more x. Now you have a 2 and 1 here. Because the boundary is also making the change. So the boundary making the change, you don't have to substitute back to make it in terms of x. You just do it in terms of u and integrate based on u. So therefore, you're going to have 1/2 integration 1 to 2 u to the 3 du. And what's even nicer is 1/2. You're going to do u to the 4th between 2 and 1. So that's going to be 1/2 u to the 4, so it'll be 2 to the 4th power. I mean, this is over 4, sorry. Minus 1 over 4. So that's equal to 1/2 times 4 minus 1 over 4, which is 15 over 4 multiplied by 1/2. So that's 15 over 8 And that's my final answer. So mainly I need you to be able to do this. I need you to be able to change your boundaries. Okay, so what I want you to do is I want you to do this one. 2 to 0, x square root 1 plus 2x squared dx. And I want to see if you know how to do this.
Wait, can you go back up?
You must change your boundary and do not convert back to x. Always do it in terms of u. Because you can evaluate at a u. Remember to change your boundaries? Did you change your boundary for the numbers? Is a nice answer? Is it easy answer? The answer is very beautiful. So u equal to what? 1 plus 2x squared, right? Du equal to 4x dx. Change the boundaries. It's going to be what? 9 and 1, right? So integration of square root of u, and then x, and this one's going to be du over 4x. X going to cancel out. Let the 1 over 4 between u to the negative 1/2 du between 1 and 9, right? So it'd be u to the 3 over 2, I mean it's not 3 over 2, 1/2 times 2 times 1 over 4 between 9 and 1. So it'd be 1/2 of square root of 9 minus square root 1. Or did I do something wrong? 3 minus 1 is 2. And that's equal to 1. The answer is pretty nice.
Did you understand?
Okay, so with that being said, I'm gonna give you a little bit more difficult one. I don't know how much time I have. How much time we have?
Yeah, 2 minutes.
Okay. So this is gonna be part of your homework. So this one, I'm gonna give you answers so that way you know if you did it right or wrong. Now this one may be a combination of two things we talked about today. So maybe combination of two things we talked about today. I give you an answer because the answer is kind of hard to guess. And it's equal to 16 over 3. That way, if you know if you did it right, you can, and you can always use decimals to use definite integrals. I'll start working on it, and you probably leave before that. U equal to 2x minus 1. Du is equal to what? 2 dx, right? So du over 2 equal to dx. And then change the boundary. So it's going to be 5 times 2 minus 1 is 9. And 1, so it's still 9, 1. Integration of square root of u. And then you got the problem with the x, and you got du over 2. So the problem is I didn't get rid of x yet, so I'm not going to change the u bound until I get rid of x. Now I'm going to say I'm going to change this to u plus 1 equal to 2x, and this one's going to be u over 2 plus 1 over 2 is equal to x. So therefore, that x is going to become 1 over square root of u times u over 2 plus 1/2. You can go if you want. And I'll record it. So 1/2 du between 1 and 5. I'm going to have 1/2. I'm going to take out another 1/2, just becomes 1/4. Just take out 1/4, and that's going to be 1 over square root of u times u plus 1 du between 1 and 5. And that's going to be u to the 1/2 plus u to the negative 1/2 between 9 and 1. So between 9 and 1. And that's going to be 1/4. This one is going to be 3 plus if I plug in 9, so it'll be 1/3 minus 1 plus 1. So it'll be 1/4. This one is gonna be 10/3 minus 2. And maybe I did something wrong. 1/4 times 2, so that's gonna be 4/3. That should be 4 outside. Something's wrong. I will have to redo this one. Let's see where it is. Have you.
No, the whole is blank.
Oh yeah, you posted the homework, you said the numbers that we have to do, but you didn't post the actual document.
I should have just posted an empty piece of paper with all the numbers on it. 11, 13,
That was really smart.
17, 19. Yeah. And then just.
That's okay. It's not that important.
Yeah, it's a 0. Sir, do you have our grades, our test grade?
Not yet. I'm not finished
You
yet.
have first grade graded.
Huh?
Max said that you gave him his score. Why don't you have us grade?
Because there's multiple choice.
I think there's a multiple standard.
Aren't we your favorite though?
Yeah, but it's harder to grade. Especially you guys make so many mistakes. Like,
Dude, the stream keeps hitting the what?